Good morning, everyone. Today I will take about the memory organization in computer system. So the foundation of the computer performance. Then we are going to discuss the memory organization. So it defines how the data moves between the CPU and the storage devices, and it determines how fast and efficient and responsive your system can be. So let's explore how different types of memory work together to achieve this balance. Yes, next is understanding the memory hierarchy. So, the computer memory is organized in a hierarchical structures like a pyramid. At the top, we have the fastest but smallest memories. So, as we have moved down, the capacity increases but the speed is decreases. Then, from top to bottom, we have registers, cache memory, main memory, and secondary storage. So, the goal of this hierarchy is simple: to get the fastest possible performance at the lowest cost. Then the next slide is key characteristics of memory hierarchy. There are three key characteristics in memory hierarchy. The one is access time, capacity, and cost per bit. So the access time means how fast the data can be retrieved. The faster memory means the faster processing that we are saying. The capacity refers to how much data can be stored, and cost per bit represents how expensive the memory is. So the speed is increases, the capacity will be decreases, and the cost will be the goes up. So the designer must carefully balance all of this. The next slide, the main memory. What is about main memory? So it is a primary workspace that we all know that. So the main memory acts as a CPU in main workspaces, connecting fast registers and slower storage. So it comes in two main types. The one type is RAM and ROM. So what is RAM means? RAM is a volatile. It loses the data when power is off, and it used to for running the active programs. So ROM means, on the other hand, is a non-volatile, and it stores the firmware and boot instruction permanently. So together they ensure the computer can start up and run the application very efficiently. So the next slide is auxiliary memory and long-term storage solutions. So auxiliary memory or a secondary storage is used for a long-term data storage. That's what we are using that. It includes solid state drives, hard disk drives, and optical media. So the optical media is like CDs, DVDs. So these devices provides a huge storage capacity at the low cost, although slower than main memory. They retain the data permanently even when power is off. That's why operating system and user data are stored here. So the next slide is associative memory, the content based access. So next we have a associate memory. It's also known as a content addressable memory or a CAM. We can call it as a CAM. Unlike a normal memory that looks up data by address. So the CAM finds the data by its actual content. It allows only the parallel searching. So it checks all the location at once for a match. It's widely used in the cache management and translation. Look aside the buffers, making the lookups much faster. The next slide is cache memory. So it's a speed accelerator. The cache memory is the bridge between the CPU and the main memory. So it stores a frequently accessed data, so the CPU does not waste the time fetching it repeatedly. So we have three levels. One is L1, L2, L3 cache. So L1 is fastest and smallest. It is built directly in the CPU core. Okay. The cache works on two ideas: temporary locality and spatial locality. So what is temporary locality means? Recently used data is reused soon. The next was the spatial locality, meaning means nearby data is likely to be used next. Then the next slide, memory type is a comprehensive comparison. So it is a comparison of all memory types. Register are the fastest but holds only a few bytes. So cache is also very fast but more expensive. Main memory offers a good balance of speed and size, but the auxiliary memory like SSDs and HDDs provides a terabytes of storage but is slower. And associate memory is though very fast, but it is costly and used in specialized areas. So the next slide is why memory organization matters. So why does the memory organization matter so much? First, it enhances the system throughout the CPU can process more instruction quickly. The next one, it reduces the latency by keeping the needed data close to the processor. The third is it optimizes CPU performance, minimizing the idle time. In short, we can say efficient memory design is the foundation for all modern computing, from smartphones to supercomputers. So the next slide is the future of memory architecture. Finally, let's look the future of the memory systems. Emerging technologies like 3D stacked memory, high bandwidth memory, and non-volatile RAM are transferring how computers handle data. So they aim to combine the speed of RAM with performance of storage. So in conclusion, memory organization is invisible force that makes the computers faster, then smarter, and more capable than ever. Yes, thank you.